Hello and welcome. My name is Nurdalila Syakirah Binti. My metric number is 243039119. I am from group T3A. Today, I will be presenting to you about the experiment that I have done with my lab partners for these past 2 weeks, which is projectile motion 1GP2. Well, the objectives of these experiments are straightforward. First, we aim to determine how the range of a projectile depends on the angle of projection. Second, we want to find out how the maximum height of the projectile varies with the projection angle. Third, we are estimating the gravitational acceleration of the Earth by analyzing the projectile's motion. And last but not least, we are examining how the initial speed affects the maximum range of the projectile. Next, we will move on to the procedure. In part A, the apparatus was first set up according to the experimental diagram in the lab manual. The steel ball was placed on the striker of the ballistic unit, and the firing spring was pulled to the first tension stage, which corresponded to the first initial speed. The distance between the striker and the center between the light barriers was measured and recorded. The angle was then adjusted to 25 degrees. The steel ball was fired, then the range and maximum height of the projection were recorded. At the same time, the experimental initial speed displayed on the speed measuring attachment was noted. This procedure was repeated for projection angle of 35 degrees, 45 degrees, 55 degrees, and 65 degrees. After completing this measurement, the experiment was repeated using the second and third tension stage to obtain data for the second and third initial speeds. All recorded values were later used to calculate the actual initial speed and to plot graph for further analysis. After that, in the part B of the experiment, the same apparatus setup was used as in part A, except now the angle of projection was fixed at 45 degrees throughout this part of the experiment. Well, first, the steel ball was placed on the striker. Then the firing spring was pulled to the first tension stage. Next, the distance between the striker and the light barriers was measured and recorded. Last but not least, the ball was then fired, and the range and experimental initial speed were recorded. This procedure was repeated for the second and third tension stages to obtain data for different initial speeds. The actual initial speeds were later calculated, and a graph of maximum range versus initial speed was plotted to study their relationship. Well, for the last part, I will be answering the questions regarding this experiment. For the first question, what do I think is the best angle of projection to start the experiment with? Well, for me, the best angle of projection to start the experiment with is 45 degrees because, according to projectile motion theory, this angle produces the maximum range. Starting with this angle makes it easier to compare experimental result with theoretical prediction and to ensure the projectile lands within a measurable distance. For the second question, suggest a way to accurately measure the height of projection of the steel ball in this experiment. The height of projection can be measured more accurately by placing a vertical scale parallel to the projectile path and observing the highest point reached by the ball. Accuracy can be further improved by using video recording, allowing the maximum height to be identified precisely from the footage. Well, for the third question, suggest a way to determine the time taken for the projectile to reach the maximum height. The time taken for the projectile to reach the maximum height can be determined when the vertical component of velocity becomes 0. This time can be calculated using the vertical motion equation. involving the initial vertical velocity and gravitational acceleration. Or it can be measured directly using video analysis. For the fourth question, from the theoretical physics point of view, will the type of material of the ball affect the range and height of the projection? Why or why not? From a theoretical physics point of view, the type of material of the ball does not affect the range or height of projection because projectile motion equations do not depend on mass or material. The motion depends only on the initial speed, angle of projection, and gravitational acceleration, assuming air resistance is negligible. For the last question, if my answer to the question of 3D was no, explain why in real experiment there are still significant discrepancy between steel and wooden balls. Well, in real-life experiment, significant discrepancy occur because the assumption of ideal projectile motion are not fully satisfied. Factors such as air resistance, energy loss during the launch, and density difference affect the motion. The wooden ball, being lighter and less dense, is more affected by air resistance than the steel ball, resulting in shorter range and lower maximum height.